either rational or quadratic or radical. So we can determine the difference quotient for that. You can look at your tests and just pick a function.
I want to say x squared
Okay,
plus 6x
awesome.
minus 42.
Perfect. What type of function did Tom pick? Quadratic. Awesome. So the difference quotient, the formula will be given to you. You don't have to memorize it.
It has something to do with the coefficients, right?
None of the above. F of x plus h minus f of x divided by h. So this is the rate of change of the function at any point where the function
So
exists.
the derivative?
Exactly. Yes, that's what it is. It is a derivative and the limit. The limit of this is the derivative. Awesome. Good. So what do I have to do next? What is my next step? I'm asked to find and simplify the difference quotient.
Let's see. Well, f of x plus h.
Exactly. If that's what you wanted to say, these two are given to us. There is nothing we can do, but we do not have this. This is my starting point. I have to find f of x plus h. I cannot stress enough, please redo all your tests numerous times. Numerous times.
Okay, so
What is my next step now? What do I have to do next?
simply substitute x for x plus h.
The other way around.
Yeah, that.
Awesome. Yes. Perfect. Perfect step. So what do I write?
X plus h squared
Very good.
plus 6
Yes.
x plus h.
Awesome.
minus 22.
Very good. Let's stop for a moment. Everyone in agreement with this? Is it a yes? Is it a no?
It's here.
Everyone that's here, yes. I'm talking only to the present people. Yes. Any questions? Are we in agreement with f of x plus h? I want to hear a yes or a no or something. Yes?
I just got back.
Okay, so we picked a quadratic function. You're right. Sorry about that. So we picked a quadratic function and we want to find the difference quotient. So this is the first topic that we would like to review. So we picked a quadratic. So now we are trying to put all three pieces together. And then after we are done, simplify. And I will ask you what needs to happen here in a minute. So now we found f of x. We started to determine f of x plus h. So we plugged in x plus h, and now we have to continue simplifying. Is everyone with me? Yes. Okay, good. So what do I have to write first? Because I have to continue. I have to simplify this. It's not simplified yet. Good. So can anyone give us the next step?
Square root x plus h.
Awesome. I'm ready whenever.
X squared plus 2xh plus h squared.
Thank you. Plus 6x plus 6h minus 42. Agreed? Is that a yes?
Yes.
Perfect. Thank you. So now we can continue. And I will continue here and simplify. So what do I have to write? Can anyone dictate?
That big old jumbled mess of variables and constants.
I agree.
Over h.
No.
Oh,
This is
minus
only
f of
this
x.
piece.
Minus f of x.
Okay.
Then
So
over
x
h.
squared plus 2xh plus h squared plus 6x plus 6h minus 42. And now,
Minus f of x, the original equation.
which is
X squared
symbol,
minus
x squared. Very good.
minus 6x
Awesome.
plus 42.
I completely agree with everything. And now h in the denominator. Perfect. Remember, two things have to happen here. Can anyone remind us what are those two things that must happen? So I know what to expect. So I don't make a mistake. And if I do, then I know I made a mistake. I'll go back and correct. Two things.
Everything remaining should have been
Everything, yes, all terms with no h must go away. Good. And then the second thing that has to happen, very good. What is the second thing that must happen in any difference quotient?
Factor for h.
Correct? And as a result of that, what will happen? Yes.
We'll get the complete difference quotient.
No?
Hmm?
It won't be in a fraction.
Yes. H from the denominator must go away. The final simplified form may still have h in it, and it will. But h from the denominator will go
And
away.
h pulled out.
Awesome. That's the answer. Good. So I see the x squared with negative x squared. I see the 6x with negative 6x and the negative 42 with positive 42. And as expected, all three terms, remaining terms, have what in common?
H.
That's why this will disappear. How many terms will I have in parentheses?
3.
Exactly 3. And they are?
2x plus h plus 6.
And that's the final answer. Very good. Any questions about this?
I think I got what I need.
Is the difference quotient clear?
Yeah.
I would go home, redo this, right? When we finish today, I would pick some other problems, some other functions, and check the answer in the book. Okay. Next topic that you would like to look at.
Circles.
Okay, very good. So we want,
Later.
here it is.
Thank you. And the chord I left?
You didn't, this is mine.
I mean, didn't I have a?
Oh, yes,
Yeah.
you,
That's yours.
no,
isn't
that's mine. Yeah, you check it out. I think you took it. Just making sure. I will be here from 3 o'clock on Tuesday.
Thank you.
3 o'clock on Tuesday.
3 till 8.
3, I'll be here from 3 o'clock on Tuesday. If you want to start at 3 o'clock, you are more than welcome to start at 3 o'clock.
When does it run till 6?
I'm sorry?
3 to 6.
I'll be here till 9. So 3 to 9 anytime.
I think I know what I need for the final. Peace out, guys.
Okay. So let's take a look at a circle. There are 3 different types of problems with a circle. And I would like you to choose one. So one of them is the center and the radius will be given. Find the equation. The second one is we are given an equation, find the center and the radius. And the third option is, which is slightly more difficult, complete the square to show that it's a perfect, that is the equation represents a circle. Which one? Which one we want to look at? So the equation is given, find the center and the radius. The center and the radius is given, find the equation. And the third one is, I'm sorry?
Find the equation.
Find the equation given the center and the radius. Okay, very good. So let's
Do you have one that's like it's not in the form, but it's the equation?
that's the third one. Complete the square to show that it represents the equation of a circle. That one, very good. So that one I cannot make it up on the spot. I have to pick a problem. So they are on page, I'll find one. I mean, I can, but it will take me a couple of minutes to make one up. I don't want to hold you. Okay, 57 on page 332. I will just have to create an equation and go backwards and distribute. But I'd rather do this. Okay, so this is an equation, and we're asked whether it represents a circle or not. So remember, the equation of a circle is x minus h, everything squared, plus y minus k, everything squared, equals radius squared. So if I manage to present this equation and make it look like this one, then I'll say, yes, it's a circle. The equation represents a circle, and I will identify the center and the radius. So x minus h, everything squared, plus y minus k, everything squared, equals r squared. So what will I have to do? As you see, this is a perfect square with a number and just x. This is a perfect square with a number and just y. And this is a number. So basically, I have to go back, collect the two terms with x, identify the middle coefficient, divide it by 2, and square it. And this is the number that I have to add to both sides in order to complete the square. So now, these three terms are here. What do you put inside? So that when we expand this, you get these three terms. If you remember on this, we signed an agreement 3 months ago. I'm ready to put it in. It's okay if you're wrong.
X plus 4.
Indeed. First term squared plus 2 times the first times the second plus the second term squared. Awesome. Thank you. Now, I'm looking at these. I have the middle coefficient, which is -2. I divide it by 2. I get -1. I square 1, and I get 1. So I have to add 1 to both sides now. So now 1, 2, 3. I can complete the square for those. And then when I move 8 to the other side, I have 17 plus 8, which is 25. So what do I put in the second set of parentheses squared?
X plus 1.
But since this is minus, you're on the right track, but this is minus. So if I put x plus 1, when I square, I will not get these.
X minus.
Correct. Very good. Is that clear?
How'd you get 25?
16 plus 1 and plus 8.
Oh, okay.
Is that okay?
Yeah.
Good.
So
So
where did 1 come from on the side? Where do we use that?
this?
Yeah.
You don't. I'm just showing the complete the square method. How you get the 1 and how you get the 16 that I'm adding. It's nothing. I'm just showing what is the procedure, what steps we have to use. Is that okay?
Yes. 100%.
Very good. So now I need to find the center and I need to find the radius. The center is,
4,
careful,
-4.
correct? And the radius is? That's it. And if I'm asked to graph, I will plot the center at -4, 1. And then 5, I will create 4 points, north, east, south, west, 5 units away. One, 2, 3, 4, 5. My circle is far from being perfect. And this is its center. Good. Good pick. Yes.
If I were to leave now,
Yes.
would I still get credit for being here? Because I'm struggling.
Everyone should go for law. Tom is a good negotiator. You're a good negotiator. A law degree is what you need. So you don't want to review, or?
No, I would love to review. I would just also love to not die from allergies.
Okay, if you're not feeling well, you can go.
Because I do think it would be beneficial to review, but
Okay,
I'm just.
good. Next topic.
Can we do a piecewise defined function?
Absolutely. Yes, a piecewise defined function is a very good idea. So here is one. So let's look at f of x equals x squared minus 1 for x less than or equal to 2, and negative x plus 2 for x greater than 2. So this is a piecewise defined function. And we want to graph it. Where do I start? What do I have to do?
I honestly don't remember at all.
Okay, so what do we have to do always when we are asked to graph a function? What is the starting point no matter what? Whenever we are asked to graph a function, what is the starting point? What do we always have to determine when we are asked to graph a function?
Domain.
Exactly. So that's my starting point, domain indeed. So let's take a look and change the first inequality into an interval notation. Thank you. And can anyone give us the interval notation for this instead of this?
Negative infinity times 2.
Very good, with a bracket. Good. Can anyone give us the interval notation for x greater than 2?
2 comma infinity.
Yes, with a parenthesis. Good. So now from here, can you identify the domain? Can we say the domain is,
Almost.
I agree, everything between negative infinity and 2. I see 2, and I see everything to the right of 2. Very good. Which x values I have to put in the chart for sure?
2.
Indeed. And also 0. 0 and 2. What are the symbols that I have to write in case you're using this method? What are the symbols that I have to put right under 2?
Bracket to the left.
Exactly. Awesome. And because it's defined everywhere, the two symbols, the parenthesis facing right, have to touch. Good. Which function? I know this is an overkill, but it's a good idea to have it in there. Which function I have to use for the left-hand side of 2?
X squared minus 1.
Obviously. Very good. And which one on the right-hand side of 2?
Negative x plus 2.
That's it. Very good. What type of function is the first one? Anyone? What type of function is x squared minus 1? Quadratic. So I have to graph x squared and then down 1. So let's pick some values. Can you give me two values left and right of 0 and also?
Negative 1.
Good.
and
Because when I plug in negative 1, what happens?
it was 0.
Perfect. When I plug in 0, so this is definitely an x-intercept. Good. When I plug in 0, I determine what?
Negative 1.
Negative 1, and that will be the y-intercept. Good. So let's plug in 1.
0.
Perfect. Now let's plug in 2. What do we get when we plug in 2?
Right.
Yes, because it's 4 minus 1, which is 3. It has to be right here inside the bracket. Now let's plug in 2 on this side.
0.
Very good. Now let's plug in another one like 3.
11.
Minus 3 plus 2.
I was still like x squared.
That's okay.
Negative 1.
Very good. Perfect. That's all we need. So let's graph. The first ordered pair that you will ask me to plot, or you will plot, will be
Negative 1, 0.
awesome. Next ordered pair.
0, negative 1.
Perfect.
1, 0.
Very good. Very good. What type of point is this one? 2 comma bracket 3.
Close.
Very good. And remember, we are graphing a quadratic function. Next ordered pair that you will ask me to plot.
2, 0.
Yes. What type of point is 2, 0?
That one will be it.
Very good, because it's a parenthesis. Awesome. And then 3 comma negative 1. See, initially when we did this a long time ago, it wasn't very clear, right? And now it's like a piece of cake. We all understand what's happening here. Okay, I'm going to also ask you, find the range. What is the range of this function?
Negative infinity.
Correct?
Right.
So cut it with horizontal lines and see from where to where. So when you cut it with horizontal lines, you will say it goes from to what? We are reviewing according to this. Thank you. Sorry, Alex, so you come in and then I wasn't thinking. Sorry about that. So range, one more time. There's an arrow that goes to infinity. There's an arrow that goes to negative infinity. Correct. Yes. Very good. Good. So far we covered piecewise defined functions, difference quotient, and the circle. So these 3. Next topic. What is the next topic that you would like to look at? Is there, again, anything from test 3 that you would like to review? All solutions are posted.
Can we do some of the logs?
Yes. Equations?
What are number 8?
Yes. Number 8. Expanding. Very good. So log base 4 of the 7th root of a to the 6th, b minus 1 to the 3rd, divided by 16. Perfect. Where is the starting point here? Remember, there are only 3 properties that we can apply. Log applied to a power, log applied to a product, and log applied to a ratio. So where is my starting point here? Which of these 3 properties has to be applied first? Log applied to a product, to a ratio, or a power? Okay, that's okay. So first I have to start by eliminating this. And that means what power? What power is the 7th root?
1/7.
Excellent. I have to put 1/7 in front. Log base 4 of a to the 6th, b minus 1 to the 3rd, divided by 16. That's the starting point. Because in order to get to this, to the inside, I have to eliminate the power first. Awesome. Great. So now, remember I have 3 properties. I already applied the power rule. I have 2 more properties. Which one goes in first? Now, from those 2. From log applied to a ratio and from log applied to a power. I'm sorry, log applied to a product. Which one? Although I can do both at the same time. Remember we said, but you may have missed that class. I said this, any quantity that comes from the top will have a positive symbol in front of the log. Any quantity that comes from the denominator will have a negative sign in front of its log. So 1/7 obviously has to wait. I'm not ready for 1/7. So now log base 4 of this plus, because I'm looking at b minus 1 to the 3rd, log base 4 of b minus 1 to the third, but now I reached 16. 16 is in the denominator. What did we put in, front?
Minus
Correct. No, log.
log.
Yes, log base 4 of 16. So these two quantities are multiplied, and they are both in the numerator. That's why their logs will have positive and positive. This quantity is in the denominator. That's why its log will have a negative in front. So now, in one step, I finished with the product and the ratio property. Now I have to go back to the power, and I have to simplify this because I can. I cannot simplify this other than put the power in front, like I did with 1/7. I cannot simplify this other than put the 3 in front, but for this one, I can simplify. Log base 4 of 16 is a number. This can be changed into an exponential equation. How do I change this into an exponential equation? If you remember, I said that this is one of the most important topics in chapter 4.
It changes to 4 raised
To whatever
whatever
equals?
16.
Perfect, excellent. I start with the base, counterclockwise, 4 raised to whatever equals 16. And now let's think. What can whatever be?
2.
2, indeed. 2, 2. So this whole thing will be replaced by 2. So I continue now. 1/7 brings 6 in front. 6 log base 4 of a plus. Bring 3 in front. 3 log base 4 of b minus 1. And I change this into 2. Once I've done that, I did not deduct points if a student stopped here, but I would rather put this 1/7 and distribute 1/7 to all 3 terms. So this is 6/7 log base 4 of a plus 3/7 log base 4 of b minus 1 minus 2/7. Some students separated this. Well, there is no rule for the difference. There is no rule for log applied to a difference. You cannot do anything. So there are only 3 rules. Log applied to a product, log applied to a ratio, and log applied to a power. Good. Next question. Next question, next topic, anything you want to pick. Oh, I didn't,
Well, I was watching you and not making notes,
oh, you mean this one?
whichever one. I think this one.
Okay.
Thank you.
You're welcome. Okay. Anything from test 3 that you would like to go back to?
Number 22.
Yes, 22. What does it say? 20, 19, 20, 22. Yes. So in 22, we have 1 plus 3 plus 5 plus dot, 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 plus 2n minus 1. And the fact that it's in parentheses, obviously, it tells us that this is the nth term. So this is the first, this is the second, this is the third, dot, 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 and this is the nth term. So with the summation notation, obviously, this is the nth term, so this is 2i minus 1 from I equals 1 through n. Let's check. When I is 1, 2 times 1 minus 1, first term. When I is 2, 2 times 2 is 4 minus 1 is 3. Check. When I is 3, 2 times 3, 6 minus 1, 5. Check. Dot, 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 when I is n, 2n minus 1. Better? Very
So
good.
I is the.
I is
where
the
it starts.
I is the floatant. When I is 1, I get this. When I is 2, I get this, and then it goes till I equals n.
Okay.
Yes. And we call it the index, to be exact. And this is the lower limit, and this is the upper limit. So the index starts at 1 and ends with n.
So the index would be its position or the actual number?
Connected to the position, but it's what I replace I by. So that's why it says I equals 1 from the first one. So when I equals 1, I get this term. When I equals 2, I get this. When I equals 3, I get this. So you're right. It has a double role. First role is I plug it in. Second one, it gives me what happens in each individual term. So the index is the one that creates the term and the position of the term. Very good. Well done. Actually, from now on, I will say that to my students. Very helpful. Thank you.
So what is the actual answer on that?
The sum from I equals 1 through n
It's just written that way.
from 2i minus 1. We are asked to condense all this into a notation using the sigma or the summation notation. Sigma because it's a Greek letter, so you can call it the sigma notation or the summation notation. It's up to you. They mean the same thing. Very good. Good pick. Anything else? Anything else from these topics? Are we still on test 3 or can we go back? Say, yes, from test 3? Yes. Number 20. So it says write the first 4 terms. So A1 is given to us. AN is 3AN minus 1 plus 3, and n is greater than or equal to 2. Like before, let's try to understand what the recursive formula is saying to us. The recursive formula says this. If this is 7, this index is 7, how much is this index?
7.
If this index is 7, how much is this one?
Negative 7. I went in here. I don't know.
Let's plug in 7 here and subtract 1.
6.
Good. If this is 10, how much is this?
9.
Good. So here's what I understand. That any term of the sequence is determined by multiplying 3 times the previous term plus 3. If this is 7 and this is 6, this is the previous term. If this is 10 and this is 9, this is the previous term. The term before 10, the 10th term. So first I have to look at the relationship and understand it. 3 times the previous term plus 3. And now I can determine any term that you want. Just name it and we'll be able to determine it. We're asked to find the first 4 terms. I have to find A1, I have to find A2, I have to find A3, and I have to find A4. How much is A1? A1 is given to us. We cannot plug in the formula 1. So if we are not given A1, we are in trouble. Here's why. 1 minus 1 is 0, and we don't have A0. Right? So A1 is 4, and there is no discussion there. Good. So now A2, remember what the formula is telling us. 3 multiplied by the previous term plus 3. Let's write it for everyone to see, and then we'll calculate it.
3 times 4
Awesome.
plus 6.
That's it. Now I can write. That's 12 plus 3, 15. Perfect. Excellent. Next one.
3
Yes?
plus 15
Awesome.
plus 6.
Very good. So 45 plus 3, 48. And the last one that we are asked to find.
3 times 48.
That's it. Whatever that is. Is it 120? 147. Good.
So what does the n greater than or equal to 2 have?
I cannot plug in this formula 1. 1 minus 1 is 0. And the first term of the sequence is never A0. It's the first term. It cannot be the 0 term. Very good. It says don't attempt to plug in 1 here because you're already given A1. Because otherwise you will not be able to start. You have to be given the first term. in order to be able to find the second one that depends on the first, and to be able to find the third one that depends on the second, and so on and so forth. Is that better?
Yes.
Okay, this is a formula that is called a recursive formula. So basically here, the sequence was not given to us by the nth term. It was given to us more sophisticated, depending on the previous term. Good, very good. Other questions, please? Other questions? Dallas, did you manage to copy this part for the log? Okay. Next question, please. Next topic, please choose. Now, would you like to look at the Gauss-Jordan?
I was just gonna say, I think we could go over 18.
Yes.
Because
Now,
I just kind of forgot what.
the sequence of steps is?
Yeah.
Yes, very good. Because it's an algorithm, right? And we may forget the algorithm. So, Dallas, I would like to do a Gauss-Jordan for you especially, and for everyone else, of course. And so you can see it's not that hard.
Well, the thing I guess I didn't get is it seems like each one, there's a different.
Right. All of them are different. Oh, yes. But the sequence of steps, if you deviate from the steps that I'm showing you, you will never solve. So the sequence of steps are carved in stone. If you try to invent something else, it's not going to work. Okay?
Calculator works great.
Good.
And I'm
Okay,
never
so
ever
let's
gonna
choose
do
a problem, or if you want the same problem, that's fine, or we can choose any problem you want. You want me to choose a problem from the book? I cannot make them up without taking some time. So I can't say for a moment in a blink. Other things I can, but not a system. Or you want the problem from the test? 18 is fine. Thank you. Thank you, Ashley, for making a decision for us. Because otherwise we would have negotiated for a while. Okay, so this is the system. X plus y plus z equals 0. And x minus y minus z equals -4. And x minus y plus z equals 2. So as I mentioned last time, if you want to use Gaussian elimination instead of Gauss-Jordan, I'm fine. So if you read the book or somebody shows you Gaussian elimination with back substitution, even if the problem says use Gauss-Jordan and you feel more comfortable with Gaussian elimination, I'm fine. Yes, Eddie?
So Gauss-Jordan is when you get zeros on the right-hand side?
Everywhere.
Okay.
Yes. The other one is more difficult.
Yeah, I think.
Because once you have to stop at some point in time and then you have to go back and replace, and I think it's more difficult. That's why.
That's an extra step.
Exactly. An extra big step, not a small step. However, if somebody understands it and is comfortable with it, I'll accept it. I will not accept guessing and plugging in numbers. That I cannot accept. But I will gladly accept one or the other. And I will put it on the final and say, feel free to use Gaussian elimination if you're comfortable with it. And I'll definitely give full credit for it. Okay, so for Gaussian elimination as well as Gauss-Jordan, I have to have the system in the correct order. So if I don't have them arranged exactly like this, I will have to rearrange the equations. That is clear, right? Everyone? Alex? Are you okay? Okay. So I start by writing the augmented matrix. If you don't want to write this, it's okay. But I like to write it so I show you what I'm doing. So this basically represents the equal symbols. Okay? So 1, 1, 1, 1, -1, -1, 1, -1, 1, 0, -4, 2. Okay. Is this clear? Is the step clear? So we have to use the coefficients. Now, before I start the algorithm, I want to explain one more thing. Of course, it has to be the one of the last. So we're going through the topics for the final exam.
Thank you.
Thank you. Okay. Remember, there are, again, only three possibilities here. Like with the logs. Log applied to a product, the ratio, or a power. Only three operations are allowed. And I cannot deviate from that. And then I'll show you the steps. Okay. What I can do is swap rows. It doesn't matter. If I consider this equation 1 or this equation 1, the solution will not change. So that's one operation. The second operation is I can multiply both sides by 3 if I want to. So if I decide to, I'm not going to do it because it's not going to help. But if I want to multiply both sides by 3 or divide both sides by 3, it's fine, right? Because I can divide or multiply both sides of an equation by a number that is non-zero. Okay, that's the second operation. The third one is the most sophisticated one. And let me show you where it's coming from so you understand why we do that. So here it is. If I want to solve the system 2x minus y equals 4, and let's say x plus 4y equals 3, by elimination, let me put here 3. If I want to solve it by elimination, which of the two variables will I eliminate? Of course. I'm not going to go into 2 and 3 because then I have to multiply this by -2 and this by 3. I don't want to do that. I want to choose the easiest route. So I will multiply this by 4. Okay, so then the next step is 8x minus 4y equals 16 and 3x plus 4y equals 3. We know that. That's the next step. Then I do this, and I get 11x equals 19, correct? That's what I'm doing here, but it doesn't look like this. So here's what we did. We multiplied one equation, both sides by 4, and we added it to a second equation, and we got a result. That's the third operation with these row operations. So I will be multiplying one row by a number and adding the result to another row to get this. So that's the concept behind the third row operation. And that's it. Swap rows, multiply or divide both sides, or multiply one row by a specific number that I need to multiply by, and adding the result to another row. Correspondingly, like we did here, 8x is added to 3x. -4y is added to 4y, and 16 is added to 3. Does it make a little bit more sense? Okay. Everyone, please, questions? Okay, so now, the sequence of steps. I'm going to put numbers next to them. Okay, step number 1 is right here. Step number 2 is here. Step number 3 is here. Step number 4 is here. Step number 5 is here. Step number 6 is here. Step number 7 is here. Step number 8 and step number 9. It must be in this specific order, or I cannot deviate from it. How do I remember this? Here's how I remember it. First, I need to obtain the 1 of the column and then the corresponding zeros. Then I have to obtain the 1 of the column and then the corresponding zeros. And then I have to obtain the 1 of the column and then the corresponding zeros. Because only this one, multiplying it by what I need, will eliminate these two and get 0 in there. Only this number will help me get the zeros here. And only this number will help me get the zeros here. Better? Now, reading these 40 pages, 20 pages, I'm exaggerating, 10 pages in the book is much more difficult than talking about it. I completely agree with that. Okay, so since I already obtained the 1 here, it was there given by the problem, I don't have to do anything about that. But I do have to obtain the corresponding zeros. Remember, like here, as you said, I multiplied this by 4. Why? Because -4y plus 4y will be 0. So that's what I want. So I know that in this step, I have to use row 1, multiply it by something, and add it to row 2. I have to multiply row 1 by something else, maybe, or the same, and add it to row 3. Exactly how you said here, multiply by 4. You have to say here, multiply by, correct. And it happens that in both cases, I need to, that's not good. I need to multiply by -1. Now, the next step will not really look like this, but this is what we're doing. It will look a little bit more difficult, but this is what we're doing. Okay, so because I'm using row 1 is the only one at this step that will not change. And this is the row that I have to copy. I copy 1110. That row will not change because I'm using it to get the corresponding zeros. Is this okay? Very good. So now carefully, I multiply and I add. So 1 times -1 plus 1. Yes, 1 times -1 plus 1, 0. 1 times -1 minus 1. Very good. We all agree so far? 1 times -1 minus 1 is -2. Is that okay? 1 times -1 minus 1. 0 times -1 minus 4. That's it. Do we all agree with this new row of 0, -2, -2, -4? Yes, Ashley, please.
Can you do that again?
Yes, of course.
Slower? I'm
Yes.
sorry.
1 times -1 added to 1. 1 times -1 added to -1. 1 times -1 added to -1.
Okay, so it's like you're taking different.
2 times 4 plus 3. -4y plus 4y, 0. 4 times 4 plus 3.
Okay.
Although it doesn't look exactly the same, but this is what we're doing. Can anyone dictate the next row? This times this, added to this.
Which one?
We are doing this part now. We are here. So this times this plus this.
Zero.
Awesome. This times this plus this.
-2.
This times this plus this.
0.
Awesome. This times this plus this.
2.
Awesome. So all this is done. Where's my next point? Next step. So I'm done with the first column. I have to move to the second column, but where is my starting point? In the middle. So I need in here to get 1. So what do I have to do? What do you recommend we do to get a 1 in there? And I can only use those 3 operations. I can swap rows, I can divide or multiply each row, or multiply a row and add it to another row. But I'm not there yet. So I want this to become 1.
Multiplied by a -1/2.
Exactly. Divide row 2 by -2. Awesome. Very good. Which row I can copy? Oh, I'm sorry, not yet. Sorry. 0, 1, 1, 2, 0, -2, 0, 2. Sorry about that. Now, I obtained the step 4, and now I'm working on 5 and 6. So I want here a 0, and I want here a 0. Which row do I use this time to get the corresponding zeros? Row 2. Absolutely. That's why I prepared the 1 in here. Good. So row 2 is multiplied by something and added to row 1, and row 2 is multiplied by something else and added to row 3. What will I multiply row 2 by to get 0 here?
-1.
Good. What do I multiply row 2 by to get 0 here? 2. Do we all agree with these two numbers? Anyone? Everyone? Yes? No? How we found these two? Okay. So remember how we found these? I had to multiply a number by this to add it here and get a 0. So it must be -1. I had to multiply this by -1 to add it here to get a 0. So now the question is, what do I multiply this by and add it here to get 0? It must be -1. What do I multiply this by to get a 0 here? Well, it must be a 2. Exactly like here. What do I multiply this by to add it here and get a 0? Well, I multiply this by 4 to add it to this to get the 0. Is that better? Okay, so let's continue now. Which row do I copy now? That will not change for sure because I'm using it. Exactly. And remember, the first column, if you destroy the first column, you're not on the right path. The first column now is carved in stone. You shouldn't even be looking at it. Okay. Let's do it together. 1 times -1 plus 1. Awesome. 1 times -1 plus 1. One more time. 1 times -1 plus 1. 2 times -1 plus 0. 2 times -1 plus 0. Very good. 1 times 2 minus 2. 1 times 2 plus 0. Perfect. 2 times 2 plus 2. Awesome. So now these two are carved in stone and done. And no one can change that. If something happens in there, we are on the wrong path. Now, what is my next step? Thank you. Yes, right here. So that's my next step. I need a 1 in here. What do I have to do to get a 1 in that particular spot? Perfect. Very good. Final step. I got the 1. I got the 0 here at the top. No one can change that. I only need a 0 here. Which row will I be using now for sure? And there is no other way. Exactly. What do I multiply row 3 by and add it to row 2 only because I don't need to do anything to row 1 so that I get the 0 right here in this spot? That's it. And that will be the final step. I'm going to try and squeeze it in here. Which row I have to copy for sure it will not change. Because I'm using it. Yes. 0, 0, 1, 3. And of course, column 1 and column 2. If something wrong happens there or something happens there, we're not on the right path. Good. 1 times -1 plus 1. 3 times -1 plus 2. I don't claim I'm right. I just claim that the solution appears to be, and I haven't checked yet, appears to be what? Yes. That's it. And then we go back and check. By hand or with a graphing calculator, you can do whatever you want. Do you feel a little bit better about it? I would redo this a few times till I get it on my own without looking anywhere, and I will choose another 5, 6, 10 problems and check
It's
the.
just a matter of memorizing all the steps.
You don't have to memorize now. So you get the 1, and that 1 will help you get the zeros. You get the 1, and that 1 will help you get the zeros. You get the 1, and that will help you. Once you apply it several times, it will stick. You will not have to memorize anything after that. So give it a shot. Other questions? Other questions here? What did I do with my... Okay, next topic. So one more time, we looked at circle, difference quotient, piecewise defined functions. We looked at some, not equations, but some logs. We looked at some sequences. I think that was it. And of course, Gauss-Jordan elimination. Okay, what else would you like to go back to?